Okay, good afternoon. Let me think. Okay, this is Thursday section. Okay, so we have to complete our calculator, finish that off. Speak a little more about getters and setters, and then in the second half, in the second half, you should be ready to do your in-class assignment today, right? So you need to do it and finish it before you leave today and submit it before you leave. Okay, so I'll just clarify a few or finish off what I was doing. So where was I? This is not yours, I think. No, I don't think so. Okay, so let's create a. Okay, so that's Tuesday. That must be yours, I think so. May 18th, 18 and 7/25. Okay, we're at the right one. Okay, so we were talking about constructors and overloading of constructors. So to refresh your memories, we were writing a small class for a calculator. And as we do that, we have to remember that a class is a definition of what does it need to work with. So it's data or how I look, if you can remember it that way, also called its instance variables or attributes. And then what can I do? So the methods, right? So keep in mind that a class is just a definition. You're trying to define its characteristics. I mean, whatever you can remember, however you can remember what its instance variables are. You can say, what can I do? Or you can say, how do I look? You can say the characteristics. You can say attributes, the data it needs to work with, whatever makes sense to you. Keep that in mind. So basically, it's instance variables, so the data it works with, and what can I do? So the methods. So we had talked about a simple calculator, and we had said a simple calculator can work with 2 numbers at a time. So you're basically, when an object is created, every object will have 2 boxes, you could think, inside it, right? Think of the object as a real entity, and these instance variables convert into boxes. You can kind of think of that boxes. However you can kind of understand it. So I had that the calculator has 2 instance variables. We are keeping to 2 rules of, not rules, they're basically 2, you could say characteristics of object-oriented programming. 1, data encapsulation, which of course every class will do. Data and methods will be encapsulated together to form a class definition. And 2, I am sticking to keeping my instance variables private, though it's not a rule. But again, this talks of the feature of object-oriented programming called data hiding. So the data is hidden from the outside world, and methods are provided to the outside world to talk to this data. So you decide what buttons or what methods will be available. Will you be allowing the outside world to change the data or just retrieve it or do whatever? So I'll stick with this class, this batch of, that kind of 2 groups. One says data should not be private. Why are you making private? What's the big deal? But I think the other one is better. I personally, that's my choice, that data should be hidden. So again, I'll stick to it. And if there is anything that's different, or I can leave it to you to think about it. But if I mention that your data must be private, please see that you make it private, right? That gives you the flexibility of hiding your data if you want to. And if you would like to show it, you can have the accessor or the get methods. If you would like the outside world to change it, then you have the set methods or the mutators as they're called. So why not go this route? It's just providing extra methods, but at least your data is safe. If you don't want, and again, the other thing, public means open to everybody, like everybody, anybody can change it, whether it's related to this object, whether it's not related. I mean, it's just an open world. Anybody can do anything. And that doesn't work for my idea of object-oriented release, right? The aim is every object must have handle over its data, and the outside world must not be able to change the state of this object, the data inside this object, till the object decides that yes. So the class decides, the class definition decides data goes inside each object, and what will be the interface or the front end or the methods that will be available for. You can even visualize a real calculator. You can think of a real calculator as if it was, so it has 4 buttons on it. It has add numbers, subtract numbers, divide numbers, multiply numbers. Then it has the set buttons, it has the get buttons. And then there are 2 boxes inside, of course, which you cannot see on a real calculator, but there are 2 boxes inside where your numbers will go, right? So this calculator class has 2 instance variables. We kind of went with double because we took care of all kind of numbers like integers and floats and doubles. Double was the biggest I can get. Of course, if it goes beyond the double capacity, if you're trying to add the 2 maximum doubles, it will give you an error because 2 maximum doubles cannot return a double value. Then you need a big. So you can go big ints, big doubles, and so on. But I'll keep it simple since we are just doing it to kind of understand what the concept is. So I had written 2 constructors and I had said that the default constructor is always there, right? Now there is no sense of initializing it to 5 and 7, but if you want to, like, you have the option of doing whatever in the default constructor. But if you do not put anything in the default constructor, by default, all numbers are initialized to 0 when an object is created. And if you create the object with this. Now, if you have another one, which I did, I have an overloaded constructor, and this overloaded constructor takes 2 numbers from whoever wants to use it and puts it in the 2 boxes inside the calculator. So when you create an calculator, now this is also not logically true. When you buy a calculator from wherever, the 2 numbers are not stored inside it. You know what I mean? Like, then there's nothing inside the calculator. But just to show you that constructors can be overloaded. So when an object of this calculator class is created, by default, you will give it 2 numbers and the 2 numbers will go and be saved inside the 2 boxes in the calculator. So that's the difference. But keep in mind, if you start creating your own constructors in a class, the default one is gone. It's done. Then it's no longer available. And you can prove it. You can kind of prove it that it's no longer available. If I remove this, so I only have 1 now, right? So you'll say, oh, the default is always available, so you don't have to put it in. But if I do this and I go back to I have an error here. It says, I don't see this constructor. You don't have this constructor. So the empty constructor is available, or the default constructor is available if and only if there is no other constructor in your class. Otherwise, it's not available. To make it available, put it in. Right? It's not that you can put it in. So you put it in, and usually the default constructor, it takes nothing and does nothing. It basically creates an object in its base state, like in its default state. All numbers are 0, all objects are null. Right? Boolean is false, and character, I think, is the non-printable character or blank. I forget, but you can check what is the default value of character in an instance variable if it's an instance. So now it's gone. I can't do it. So to go back, I'll go back to my calculator and I'll kind of uncomment my empty one, and now I'm okay. So now I can create calculators, right? Okay, we had talked about set methods, and in its simplest form, the set method, because there is no data validation here at all, right? I'm not doing any data validation. Every number is a number. The set method can have validation in it. You may need to. So what you will do is, and again, see, I'm calling them from the calculator. I don't rewrite the code here, though it's only 1 line of code. I could have just copied and pasted it there, but I don't. Again, keep this design principle in mind. You don't repeat code. Copying and pasting is easy, I know, but you don't repeat code. Because the job is that every method does a job, and let it do its job. And if it is required to be invoked, it is required to use it somewhere else, invoke the method. So constructor can call the set method. So it says, set, you do this, that's your job. I'll take your help when I need to set my number 1. And the advantage is you can also set the number from outside the class definition. It's not a private method, it's a public method, right? Now, if you wanted to do some validation here, just for the heck of it, I'm just doing it because I want to show you. You would just like add a normal if statement. So you're saying if my number 1 is greater than 0, I mean, I'm just doing it. I'm just restricting it. Then set it. You may have an else. You may say else my number 1 is always set to. I mean, of course, it will, your application will decide what you want to do. I'm just setting it to 10 for the heck of it. Okay. Now you could have validation like this. And that's another definite use of set methods. They take your input. So each set method will set 1 instance variable. So you write as many sets if you need, of course, if you need to set the instance variables. If you decide, no, this cannot be changed, then you don't provide a set method for it. You could create a private set method for it, still just keeping in mind that everything is done in the set method and the constructor will call the set method. You could do that. It will also help when you do inheritance and all that. So you could create a private one if you like, but you don't have to if you don't feel the need of it. But the maximum set methods that you can have in a class are the number of instance variables. They could be less, but they can never be more. And therefore, a constructor that constructs an object calls the set methods if it has any parameters coming in. Because what is it trying to do? It is trying to create an object, and then inside the object, it is trying to initialize all its instance variables. That's what it is doing. That's what a constructor is. Construct an object and initialize its instance variables to a valid value. If you don't initialize it, they take their default values. So does a constructor only come in two forms? One, the empty one that does nothing, I mean, gives the default values, and one that takes all the instance variables? No, you could have anything. You could be taking one instance variable, or you could decide, oh, I only will take number 1, number 2 will be 5 always. Like, you can do whatever you like, as long as it's logical, right? So when you're creating constructors, thinking, what are the various ways in which I will be able to construct the objects of my class? You're thinking. So therefore, in the API, you will notice that some classes have a single constructor, but most of the classes have quite a bit of constructors. It's just saying you have the option of creating it this way, or creating it this way, or creating it this way. So you decide what constructors you need for your class definition. And it's not a must that it must always be overloaded, or the more constructors you have, the better the class definition is. There's nothing like that. I mean, there's nothing which says that. You decide how my object will get created. When it is created, what should I be putting inside it? Do I need to initialize it? No, you don't need any constructors. Do I need to initialize something with a default value? Sure, go ahead and do it, right? Okay, so now look at what I've done. I've done a small kind of little bit of validation in my set method. So when you try to create an object, still your number 1 can, if it is greater than 0, it will be used. Otherwise, it will be set to a default value of 10. But else is not required. We all know if necessarily doesn't need an else. If you don't want to do anything, just comment this out. We don't need to. You may only have this. So you're basically saying, I will change the number 1, or I'll set it for the first time if you give me a value greater than 0. Greater than 0. If you give me a negative value or a 0 value, I won't touch the previous value. So if it is the first time setting of the object, your value will remain at 0. If you already gave it a value like 20 and then you're changing it again and you're giving it a negative value, it will not change. It will stay at 20. So the set method is basically a method that changes the data inside the method, inside the object. Think about it. An object needs to be, you need to work with the object. You need to work with the calculator. So unless you change the numbers inside it, it's a useless calculator. So you'll say, how will I change it? There has to be a button on the calculator which says change number 1, change number 2. And those are these methods. We call them the set methods. When you create the calculator for the first time, it needs to become active, or it needs to take birth. That's what we say. It needs to be constructed. So we need a constructor. And maybe if you don't want to set any numbers, the default will be 0. Right? The default will be 0. So those are the uses of constructor, and this is the use of set. The set methods will validate the values that go inside instance variables. For me, I didn't need anything because I was working with the calculator, but this could be handy in something if you're trying to set the age of a person. Age of a person cannot be negative, right? Of course, it will be an int. It needn't be a double at all, but the age cannot be negative. So you create an object, person, you give it an age of, say, 0 to start with. That's okay. And then you try to set it to -10. How can that happen? It cannot. You cannot give it a value. So your set methods do data validation. That's the extra work they do. Okay. Your get methods retrieve the values of your. So notice now this validation will work everywhere. If you're trying to construct a new object, it will be called. If you are calling it from, if you're trying to set both the numbers, it will again be called. So irrespective of whether the object is being created or values inside them are being changed, the set method is always validating data. And that's the use of writing the code at one place and calling it from the constructor, calling it from set numbers, or calling it from wherever you like. So the data validation only happens at one place. I could have taken these 3 lines and put them here too. You could say, oh, why don't you just copy and paste this in your set numbers also, in your set both numbers, or in your constructor also. I don't want to see that. That's not how you, that's not a good designing at all. That's not how you code. right? And that's the main thing. Let one method do one job and let it be invoked or called from wherever it requires to be called. What would get do? How could you improve your get if you wanted to? Mine are again doing very simple jobs. They're just returning number one, like just returning it. But you could do this just to show you. I'll comment it out afterwards. So a different get method could be doing this. You write a get number one and use return something like the first number is where? Oops. Where? Oh, it has the see it says bring your mouse over it. It says this method is already defined. If you are going to overload methods, the parameter list has to be different. The type doesn't matter. That was returning a double, this is returning a string, but there has to be something different in the parameter list. So just for the heck of it, just because I want to make it different, I'll just call it here. Now it won't complain. Now this is get methods never have parameters. We know that they never have parameters, right? So that's just to show you that your get number one would be doing something like this. It returns you a string and it says the first number is and shows you the whole number. Right? So get methods could be returning your number in a different way. Instead of just saying return double, I'm now returning a string. And that can be done in get methods. Now, for whatever reason, suppose I change my doubles to big doubles or something, I change their type. Then I'll have to go and change the type here also. Here also, I'll have to change this double to something else. Maybe float, whatever, I have to change it. But here I'm safe. Do I have to change this method if my method was returning, say, it in string? No, because the type changes, but I don't have to change my method at all. So usually get methods are again written keeping this in mind, that they're trying to show your data in a format-free, independent manner. So you could change the type of the data in your class and your get method does not change. It doesn't. So there are advantages. I mean, the set and gets are just not return this and assign. They're not simple statements like that. They have uses. Set methods definitely have uses because they validate your data. And the get methods depends. What would you like to do with it? Even if it is as simple as return number one, if you don't have the get method, how will you show the value of a private variable if you wanted to show it to the outside one? How would you show it? There is no other way. If you don't have a get, can anybody out from the outside see your value? No, because it's private. So if you would like to show it, then you have to have a get. But they are a little dependent upon the data inside. This says that number one is a double because the return type is double. Now, another thing that you may notice if you're going to do some, I don't know, if you're going to do some research, some programmers kind of go overboard according to me, but this is what they do. They don't use the instance variables even inside the class. They use the accessor inside the class. They don't even use they say wherever you are going to refer to a variable, even inside class definition, use the accessor method. I think that's going really overboard in the sense that I'm right in the class, the definition is right there, the numbers are right there. Why did I call the accessor method? But you will find this, many people do this. They don't use the variable names in the code, even in the code, they use the accessor methods everywhere. And detail, the textbook, they're fond of it. They do it quite often. They use accessor methods everywhere. I don't know. I'm just not in the, I don't say habit, I just say I find it an overkill. Like, what do you need? Because these, I mean, if I change my get number one to something like the first number is and change it to string, then of course I cannot use it. This is assuming that your get methods are only returning values. So I say, why even bother about it? So I kind of, when inside a class definition, I tend to use my instance variables because there's no problem in it. There is no disadvantage in it, right? And I don't see any advantage in using the get methods. But if you find that, don't be like, it's perfectly fine. There's nothing wrong in it. Syntactically, it is fine. Logically also, it's fine. It's just an overkill according to me. But if you see it, because somebody asked me in the other section that everywhere they had get, and he said, why are they doing it? Just a programming practice or a preference, you could say. And you could do it. A class can call its own methods inside it. Now, the one that I was talking about here, I just had it at the wrong place. That's why it wasn't working. Here, it's an O with a capital O, and it's outside your Java document. Let's talk about this toString method that I would like you to almost override in every class definition that you create. right? So let's look at what is this toString method. Okay. Now there is a toString method in the object class. Remember the object class from Java? It is the class that sits at the head of every configure like hierarchy. So if I go to Java, maybe I should just download it. Oops. So let's search for Java or for object. Maybe you've never even looked at it. Though we keep saying that the object class is the father or the mother of all classes, I'm not even sure whether you've ever. There it is. There is the object class. Do you notice its hierarchy? This is the only class in Java that doesn't have a hierarchy because it's at the top, right? So you'll never see a hierarchy like any other class. If you pick up any other class, like let's just pick up this one. See, you will always see some kind of hierarchy. The object class will sit at the head and be one or two or more or whatever. But object is the only class that doesn't have a hierarchy because that's the only class that does not inherit from any other class in Java. All other classes inherit from Java. Now notice here, there are a few methods here. So you have a constructor, which is the default one. You will hardly ever, never ever create new object because we always have objects of some kind, right? This is the generic name, object. So we'll never ever need it, but the constructor is available. So therefore no other constructors are written. Then it has a few methods. It has a method called clone. Clone allows you to create a copy of the object. Maybe you've never done it because you're not at that stage yet, but the clone method allows you to make a copy of an object, like a duplicate of an object. For example, you have not used it, but what else could you have used? I don't think anything else. I don't know whether you've ever used get class. You can always get the class to which an object belongs by using this method called get class. It's a method that is available. It returns the runtime class of the object. So if I create a class, I'll show you how to use it. It's not a big deal. I'll show you how to use it. It will get you the class. It will tell you that I belong to the class this. That's get class. Look at this method now. The method that I want to kind of basically override. So there is a method called toString in the object class, which basically does what? The toString method for class object returns a string consisting of the name of the class to which the object is an instance, @character, and the unsigned hexadecimal representation of the hash code of the object. In layman language, you can kind of assume it's the address of the object. Okay, that's what it means. And did I show you last time what it returns without overwriting it? So if you just try to write it in your tester, so, I have kind of commented it. Let me comment it. Let me not put anything. There. Right, so I've commented it. Let's go back to the test. Why is tester still saying you don't have this? Okay, now it's fine. Okay, so we have two calculators. We displayed the result. We changed the numbers. We displayed the results again here. Let's see what this does now. There is no toString method in your class, but I'm calling it. And you could actually also call it without toString. You can just call it like this. I'll copy this so that I can put it in comments. You can call it like this. This is the only place where you will see that an object name is called without a method name. Right? Kind of looks odd, but it's allowed. It automatically assumes that you're calling like this. That's what it assumes. You can use it anywhere. You can just say cal1 and it will call the toString method. Now let's see what it does. Let's try to run it. And where are you? There. Notice this. This is what is happening with the toString call. Why? It doesn't have a toString. And how does it work? It goes and looks at the parent of the calculator class. And the parent of the calculator class is object. And there is a method toString in the object class. So it automatically calls. That's inheritance. If a particular class doesn't have a method, it says, parent, do you have it? Sure. Can I use yours? That's what inheritance is all about. Okay. So that's what it brings. Now that's not what you would like to show to your user. So the use of a toString method, usually it's called toString because it gives you a string representation of the data inside the object. So you're kind of showing the data inside the object in a string format. That's all you're doing. Therefore, it's called toString. You cannot change its signatures. You cannot. If you try to, it will come up with an error. So this annotation @override says that you cannot change the definition of the method. If you don't write override, then of course it's okay. Then it's just a method, right? But if I do this, I can do this. I can't. It will come up with an error. It says you're trying to override the toString method of the object class, but you've changed its return type. You can do that. If you don't use override, then of course, now it will say because I'm returning a string, that's why. Right? Now what is it saying? ToString in calculator can, oh, because it is called ToString. So if you want to do something else, you will have to kind of give it a different name. Otherwise, it assumes as soon as you use the name ToString, it says, oh, you're trying to override the ToString in your parent class. So you've learned overloading. Overloading means giving a different definition to a method inside the class. So therefore, it's called overload. So the same name, but different definitions. Different parameters, different definitions. Overloading just means you don't want to think of new names, same kind of job, right? Like in message box, right? When you were with the dialog J option pane, when you were showing an input dialog box, what was the difference? The difference was minor. One had a title, you could change the title, you could change the icon, but they're doing the same job. They're showing you a dialog box on the screen and taking input from the user. Since the job is the same, why not call the methods the same? Just overload them, give them different parameters. This is called overriding. Overriding says I'm going to change the definition of a method that belongs to my parent or grandparent, whatever class. Inheritance can be any levels. You could be changing a method of your immediate parent, grandparent, great grandparent, or whatever. This is called overriding. So I can't use the name ToString, the method to, I cannot do it because it belongs to the parent and your class has inherited from that parent. By default, all classes inherit from object. So if you want to not use it, it's up to you. It's not necessary. Some people don't write it at all. They give it a different name like display data, which is, why do it? I mean, if there is a method that is available, why not just change it? And that's exactly what I'm doing here. So mostly in all your assignments, you will be required to write a ToString method. And the ToString method will do something coming out of your data. So notice what it says. It says the two numbers are this and this. That's all it does. I could maybe format it better because they are doubles. So let's create a string variable. Call it message. Format it. I find printfs and formatting better than just writing it this way. And it's easier and it's I think it's more clear also. Okay, so let's do it here. Let's put it here. So, okay, so the two numbers are, and the advantage is I can go without this pluses and everything. I find that really advantageous. I don't have to kind of think of it. I just type it in as if I was typing so format it with 2 places after decimal and format it with 2 places of decimal. And now put a comma and then give your argument list. Now here, if you like, use the get number one method. In ToStrings, people tend to use the accessor methods mostly. You don't have to, but at least this way you can remember, oh, I can use it. Just so that you can see that it can be done. Okay, just so that you can see it can be done. And then what will you do? You will return the message. Always format and return your answers. Oops, spelling of get is wrong. Now I have overridden the ToString method. The ToString method does return the string representation. Therefore, it's called ToString. String representation of the data. So you're basically saying I'm going to return a string with showing you the data. That's all it does, right? And those are the only 2 data items, excuse me, in my class. So I just say the 2 numbers are, I create a string. Oh, sorry. Do I have an extra bracket somewhere? Yeah, there. Why doesn't it complain? Now it is complaining. So what am I missing? Oh, I need it, string.format. Okay. I format my string because I don't want to have more I mean, you can decide 2 or 3 or 4. I'm just going to. So I want to show my data in a readable, like friendly, readable format, and I use the point to L. Yes.
It have to be the 2 numbers are plus.
Oh, thank you. Yeah. We don't even need this, right? There. Thank you. This return kind of confuses me. I know it's good for you. And Rick brought it up, and it's really good that I don't have to think about it, but I get confused with it. It just looks odd. That's okay. There. So that's my formatted string. So that's the use of the toString method. So you can kind of put your comments here. You don't have to something that's overridden. You can actually kind of point to, there is a way of pointing to the Java doc comments of the toString method of the object. I kind of forget now, but you can do it because this is an overridden method. And the toString method in the object class already has Java documentation. You can refer to that. But I can't remember how it was done. I'll look it up. I'll Google it. You kind of make some @ and then you say refer to that. So this method returns a string representation or just returns the data. Like let's English returns the two numbers. That's what it does, right? Kind of. And then we don't have a parameter, but we have an @ return. A string. Not represented or containing the two numbers, something like that. And that's what usually is the use of the toString. Oops. That's usually the use of a toString method in a class definition. And it's called toString because it kind of makes sense. The name makes sense. And it's better not to give it a new name because its functionality is giving the data, showing the data. And since the father class object has already defined a method called toString, why not just override it? So it's common. So you'll almost find it in every class definition, right? But that's what it will be. It won't be a new different method by a different name. So now you know override. You don't have to give this annotation, but by giving this, you ensure that you don't make any mistake in its signature. That you will ensure you don't make any mistake. So it exactly has to match the signatures of your toString method in the object class. And those are the signatures. Now, if I go and use it, I can still use it. I don't have to still say dot toString. I just don't have to do it automatically. When you see it here, it will call it. Let's call it. And now you will see the two numbers are there. It is. Right? It shows you the two numbers. So that's the toString method that you will find in almost all class definitions. It's not a must. It's not a must. It's just a convenience. Right? So you're showing the data. So I only had two variables. If there were more than two, maybe there were 10, I could maybe create them in different lines or something, make it however I want to return it. But it has to return, keep that in mind, it has to return a string. Before I forget, did any of you come to my office today looking for me or to meet Jarrett or Rich in my office? No, okay. Somebody has left their lunch on my table. Like I was away for class, when I came back, there was somebody's lunch sitting there. That means somebody came in, like a student came in and they forgot their lunch.
Oh, I think that was me.
Oh, okay, sure. Come tell it.
It was a monster drink, right? And yogurt, right?
Yes, it was yours. Okay, so I've kept it in. Oh, I'm glad. I've been thinking, what do I do with it? Like I wanted to eat it, but I didn't want to. So in the, no, that's okay. In the break, I went and kept it in somebody's fridge in another office so that it wouldn't spoil. So in the break, I'll go and get it. I'm glad I have found the owner. I thought, oh, I must ask. I had no clue who was there.
Yeah, like, oh, what happened to my monster drink?
Yeah, it's a monster drink and a yogurt muffin. I'm saying somebody left it for me, but if they did, they would have said enjoy or something, you know, they would have left a message for me. So I thought, who is it? I don't have friends here who will leave lunch for me. I'm thinking must be some student. It was on my table at the corner, like on my side. So I thought it was mine. Good, I didn't eat it. So remind me, I'll get it during the break, okay? I thought I would either, like, what do I do? So I kept it in somebody's fridge. We don't have a fridge in our office. So I'll get it. Now you can have it during the break. Okay, good. Okay, so there, is that clear then? What did I do? I just kind of wrote a toString method, and then we've already learned all this. I'll refresh your memories very, very quickly. I wrote a helper method. I said a helper method is always good to write when you have to show values because you're going to call it over and over again. You don't have to. We've already talked about that it should be static in nature, though I showed you how you could kind of do it without a static. Kind of messy, but it can be done. Right? In the test calculator class, I created an object of the test calculator and then called it. There's nothing wrong in it. Though it's, as I said, class and the class is creating an object of it in itself. That kind of looks odd, but it can be done. So I've commented that out. So Cal1, I show results. I change the numbers to 5 and 7. I display the results. And then I again, oh, this was just the toString method. For Cal2, I showed the results and then I set the numbers, right? So it can take an integer. It can take a float. Are you aware that to pass a floating literal, you have to put F with it? 2.5 without an F represents a double number, which is fine for us. We wanted to pass a double, but if you want to pass a float ever to a parameter, as an argument, you have to put F with it. You can't work without an F. Every one of them, I think, has something, an L and an F, but I remember F because the others are okay. For a long integer, I think it is an L. So these are short forms that you have to put. Otherwise, it doesn't recognize it to be a floating point literal. I'm talking constants. I'm talking about literals. So and this will work because a floating point can go into a double, but I'm not sure if you know about it. So to pass a floating point number as a value into maybe a floating point box or a double box, if you want to pass it, you have to put F with it. Right? Maybe it will come handy in something else. Maybe, I don't know, maybe in your assignment today. But that's how you pass floating numbers as an argument. You have to put F with it. And again, if you were using something else like 2 is an integer, but if you want to represent it as a short integer or as a long integer, then I think you put L or something with it. Double check. I think it's an L for long integer. I could be wrong. Like, because every language has something, and I can remember for sure C# has an L, but maybe Java. I think it's the same, right? So now my tester is working as it should work. The only thing that isn't good in this tester is this, or in this class definition is this, the NA. And you know what? This N is still okay. I don't see an error or something. But if I change my types to int, it will throw exceptions. It will throw exceptions. So I'll show you how you can take care of this. It's not a big deal, but it's a topic in itself. But all you have to do is change which method here in your calculator. Which method is doing division? This one. So changes have to come to this method. Otherwise, everything is okay. You can add two numbers. You can add to subtract two numbers, multiply. It doesn't matter if one of them is 0. But in division, number 2 should not be 0. Number 1 can be 0. Number 1 can be 0. But number 2 should not be 0. And we've always learned that in math. We've said number 2 can never be. You cannot divide something in 0 groups. You know what I mean? Therefore, it is illogical. But for doubles and floats, Java gives the output as NaN. So if you would like to stop your program and say, oh, that's not good, you could always throw an exception and it can do. So exception throwing is a little more complicated. I'm hoping to do it in my next example. But all you have to do is say, stop it. You can't go on. So if you give a 0 input for number 2, the program is stopped. It doesn't stop here because it gives an NaN back. But you can do it. You can say that's not how it is. It's just telling the user something went wrong, right? And the program gracefully stops. So there's a difference between a program stopping abruptly with all your errors coming in red in the output box, or your program just gracefully stopping and saying, sorry, I cannot do it. That's the difference. It still has to stop. Okay, here you don't see it at all because you know what? Doubles are working so pretty. Like you can work with doubles and they automatically give you not a number. They actually also give you infinity. You will also see a result of infinity. When will infinity come? When you try to divide by infinity means a very large number. How can you show? How can I show you a result of infinity in my code? If I try to divide by 0 is not a 0. Okay, let's try the opposite. Let me try this. And it's kind of, I mean, that's not how it should be, but whatever it is. So let me keep my number 1 and number 2 as 0. Division by 0 should give you infinity, right? So I've taken my calculator 1 and I've changed it from 0, 0. 0 divided by 0 is giving an NaN. I think 5 divided by 0 should give you infinity. Let's try, as far as I can remember. See? So it spits out the word infinity. So now to a common user, NaN means nothing. Like mathematically, I know what infinity is, but to a common user, infinity means nothing. The error message the user should see is 0 your second number cannot be 0, or division cannot be performed with 0. I mean, that's what the user should see. But this only happens, I'm not sure if it's changed in 1.8. I don't think I read about it. I could be wrong. I can't change the whole thing, but it will not work with integers. If your data was ints instead of doubles, it will start giving you problems. So I don't know. I don't like this concept that why did they do it in floats and not in doubles, or why should they even do it? They should just say that division by 0 is not allowed. But they're doing it in doubles. So I know what infinity is and I know what NaN is, but a common user doesn't know what NaN is. but assuming that whoever uses a calculator does have an idea of what it means, right? So I don't know what happens in our calculators. What happens? Have you tried ever dividing numbers by 0? So if I say 9 divided by 0, what do I see? Cannot divide. So this is what you should show a user, right? Makes more sense to a common user. Cannot divide by 0. And you can do it. It's not a big deal at all. It's very simple. It's very simple. And that simplicity is just this. You say if my number 2, oh, sorry, yeah, number 2, yeah. So negatives are allowed, okay? It's the positive that is not allowed. Java, not equal to. Those, okay, so not equal to. I'll just show you how it is done, but of course there is more to it. Else you can just kind of throw. Those are the verb. It says throw an exception. Throw just means return, kind of, right? The throw word is for exception. You can say throw. You are creating a new exception object. It's a kind of an arithmetic exception, right? Therefore, I said there is more, but maybe just like as if you were doing it in, like reading it in English. Uh-oh. Right now, the difference between printing out a message on the screen cannot divide by 0 and throwing is this. The message will print on the screen and then it will kind of go forward, right? Execution will kind of continue. But throw stops the execution of the program. It stops. It says it doesn't make sense. It's done. I can do it. So you have to decide, do I only want to show a message or do I want to stop my code? And again, situations will be different. 2, something that you must remember. Now this method is returning a double value, right? So how will you return a message like division by 0 is not allowed? You cannot return 2 different things in a method. One is returning a double value and the other is returning a message. And printing in classes is a big no-no. Have you ever seen in any Java class that you've used? Go through those thousands of classes there are in Java application. None of the classes will have a print statement. They don't have a print statement. Why? Because I may be using a method to print something, but you may method just to get the value. So what methods do, they just give you the value. Whoever is using the method, the value is given back. You decide as a programmer, do you want to print this value? Do you want to use it in a further further calculation and so on? So system out println is not used in class definitions. Never. Look at the sense of it. It's saying, what if you still want to have something back with the, so I could have said here, the answer is number 1 divided by number 2. I didn't do that. I didn't say the answer is. I didn't say the quotient is. I'm not doing any printing in my class. Notice I don't do any printing in my class. All my class methods do are do a job and return something. That's the job of a method. All printing is done where? Application. Every printing is done in the application. Therefore, we write applications, right? And that's how it is. So I could have said here else write system out write ln division cannot be done, but I choose not to for two important reasons. One, class definitions don't have any printing. Never, no system out printlns. That's how the norm is. Because we don't know what does the user of the method want to do with that return value. So just return the value and let the user decide what they want to do. And 2, if I want to stop my program, that's the only way I can stop. I'll show you how it works. So it will stop when I try to divide numbers. Now, when I give a throw here, let me just double check. So basically what it is saying is that when this method encounters a counter condition, not equal to 0 means it is equal to 0. It is going to throw an exception object. I created a new exception object right here. I know there is an exception called arithmetic exception in Java. So I kind of used it because its name was good. Arithmetic exception makes sense, right? It's an arithmetic exception I'm getting. So when this method is called, from where is it called? It is called from here. When it's called from here and you give it a 0 value, it's going to print out, it's going to return that object with that message, cannot divide by 0 here. And this knows, main method knows that whenever I get an exception, I should stop. And it will stop. So let's try running it now. It should actually stop at the first instance itself. Why? Cal1's both values are 0 and 0. Cal1, both values are 0 and 0. Try. See, now, oh, okay, I see what it has done. I forgot something. See, now it started to work with 0 and 0. It said the first number was 0 in that printing. The second number was 0. The sum was 0. The difference is 0. The product is 0. When it came to division, it got, I said, throw an exception. It threw an exception, and where is my message? Cannot divide by 0. Of course, it's not looking pretty. I can make it look pretty, but that's what it has done. It has stopped. It has not divided by 0. So it stops as soon as it finds invalid input. Right? It finds invalid input. Here, my messages are not clean. This is what we will learn. We don't want to show the user these messages. We only want to show the user this message. This message cannot divide by 0. So we will learn. I've just thrown it to show you that how you can stop it, but we will learn how to make a graceful exit. Graceful exit means all this will go away and you will only see the message cannot divide by 0. That's all. So that's graceful termination of a program. And that's what we have to learn using exception handling. And I'll start exception handling, though I haven't mentioned it almost till my second half. I'll start doing it next week onwards, so that you get the knack of it. By the time we do it completely, you already know the basics. And this was just a very basic example. So the program stops, it doesn't go forward. So irrespective of whether you are using integers or reals, I'll say, no, division by 0 is not allowed. I don't want the user to see NaN or infinity. I'll just say division by 0 is not allowed. It's not a big job. It can be done very easily. It's just a little more work. And then the more I do, the more I'll have to explain to you. So I'll kind of shut up here and just leave it here. So you could do this. Okay, so that you know I can stop a program if I want. A little more gracefully, but I can do it. So then you don't see NaNs or you don't see infinity. The program just stops and says cannot divide by 0. If you say, no, I don't want to stop it, maybe I want to ask the user again for 2 numbers. Here I'm doing all hard coding. I'm not asking the user at all. I'm just writing it. I'm just coding it. You can put it in a loop and you can say, okay, ask again, and ask again. So it will give you the message divide by 0, but ask you the next 2 numbers. If it is possible, we'll show you the results. Else, we'll say cannot divide by 0, and so on. So you can keep it in a loop also. You learn to do all that in application. But this is exception handling. So if you don't want to see NaN and infinity, this is how you would do it. I've just mentioned it, guys, but we'll do it. We'll do it in detail. Okay. Okay. Having said that, any other question that needs to be asked in this one that's not clear? That's something. So I've told you how you could validate your data in the set. If it is given to you, use it. Else do something, otherwise don't write the else at all, right? Because in the assignment, I asked you to set the value of salary of an employee, and if the salaries cannot be negative, so you will need that. Gets, if nothing is asked, get methods will always almost return the value, return whatever variable. If it is asked that please write a get method that returns a string or something, then you have to change it. But if not, accessor methods, you can use accessor methods in your class code also. You can keep saying get everywhere you want. I don't do it, but I'm not stopping you from doing it. If you want to, please go ahead and use get methods instead of variable names everywhere in your code. But in the toString method, I prefer to do it because it's basically saying, maybe my get method returns the first number is, then I just say return get number 1. You know what? I can use it. I can use it in it. So in the toString, I usually make it a practice to use it, but otherwise I don't use accessor methods in my code. When inherit, talk about it. So please don't get bogged down from this if you see it somewhere. All it is doing is, instead of using number 1 and number 2, it's using its accessor methods. And it is an overkill. I mean, in the same definition, but it's there. It can be done, so you should be aware of it. As I said, another student had asked me, maybe he read it somewhere. And actually, NetBeans also has the option of writing your getters and setters with accessors. It replaces them everywhere. There's a checkbox there. You can say, yeah, use it everywhere, and it will use it everywhere. So NetBeans has it, and maybe there is where the students saw it. But anyway, that's okay. So I just wanted to show you. So you do know about, oh, this is where is this? Why is this giving an error? Why do I have a red squiggly here? Else. Oh, there is an if. Oops. Therefore, there. I've commented out my data validation here. The other thing is, why don't you validate your data in the application before sending it to the class, right? Check. The two numbers, are they zero? Don't even call the division method. That's another way of thinking. But let me tell you why you should go this route. A class should be independent of anything, whoever calls it. It should do all the error checking by itself. It doesn't. Okay, so if I write a class and I say, okay, William will check his data before he sends it to my methods. Good, so I'm safe there. But Oscar decides not to do any validation and says the class will do the validation. So who decides, does the class do the validation or does the application do the validation? So when classes are created, the programmers assume, I'm not sure who's going to use my class. So let me do all data validation inside. And that's why classes do all the data validation. That doesn't stop you from doing validation on the front end also. Front end means the application you're writing, the tester you're writing. But the person who writes the class assumes that because he has no idea who's going to use my class. So he just says, I need to be on the safe side, I'll do the validation myself. So therefore, make it a point that your data validation is done in the methods also. So if age cannot be negative, check it in your set method. Don't rely on the application on the front end to say, only positive ages will be sent, only positive ages will be set. Who knows? As I said, some you cannot assume that the application programmer who's writing the front end will do the data validation. So why rely on somebody? So all classes do all their validation themselves. And that's what we will also do. Our classes will do the validation. If you want to repeat it in your tester, that's up to you. But why would you, right? That's how you think. That's how you create classes. As I said, always assume that the user is out there to break your code. Never to listen to instructions. And you will always be safe. That way you will do defensive programming. You will always write code that is 100% correct. You're saying, I don't know what will happen, so let me do this also, and let me do this also, and let me do this also. Since I know NaN and infinity are not valid answers to a user who doesn't understand what they mean, I said, why not return something like division by 0 is not allowed? And I'm safe, right? I'm not relying on anybody. My class is complete in itself. So when you create a class, ensure that your class definition is complete. Does all error checking, everything. And second thing to remember, no printing statements in a class definition. There is not a single class in the Java API that has printing. Because the option is, let the programmer at the front end decide what he wants to do with the return value. If he or she wants to print it, let them. If they want to use it in a further calculation, sure. If they want to print it and use it, sure. So you don't decide. You just give the just return it. Let the front-end programmer decide how they want to or what they want to do with it. So no printing in the class definitions. And if somebody is doing it in a book or you see it somewhere, it's horrible programming practice. Like I remember a book we used to use long back. That's why we kind of rejected it. All printing was being done in classes. And there's no class ever. I've never seen a class in Java doing it. And why? Right? Why should you do it? The printing has not to be done by the class. It's not the job of the class methods to do it. Method does a job and says, here is the output. So you decide what you want to do. You've used a few classes yourself. Have you ever seen anything being printed from the method? No. Methods always return something. Or they don't return anything, void, but they do a job, but they never print it. So I don't want to do, don't want to see, don't make it a habit. If you are in the habit of doing it from your first programming fundamentals, forget about it. It doesn't exist. No printing in class definitions, okay? And of course, in application, it will be full of prints. What else will it be full of? I'll do printing everywhere because I'm showing my answers. So let this do whatever printing has to be done. And this class only kind of does a few things, right? So we will come back to this. I just wanted to mention it because you have control over what you want to do with your methods. So if you don't want to see the NaN and the infinity, you can control it. I'll just tell you how to make it better, like how to show it better. But I can give my own messages and make it look better, right? Okay, that takes care of what I wanted to do, at least as a starting class definition for the assignment. So I had to kind of postpone the assignment because I wasn't sure whether you knew how to write all this. So hopefully this will help. So I'm going to put this example. The dialog box example is already up. I'm going to put this example on Blackboard for your reference. You can take a break if you like right now and then start your project and it has to be done and completed and submitted by 3:50 before you leave. Okay, yes. You're not submitting this. You are going to submit an assignment that I'm going to give you. So I'll give you an example you'll do an assignment, a real exam, and that's what I need from you. Okay. You can take a break if you like. I'm going to put your assignment up on Blackboard. Sure.
I was